A very good day to Dr. Intan. We are happy to present to you our project with title of Analysis Case Studies of Ollie's e-commerce store. We are Group 4 comprises of 4 members from the School of Computer Science, USM.
Electric commerce is the purchasing and selling of goods and services over the internet. Despite the fact that there is no universally accepted definition of e-commerce, experts generally agree that the major components of e-commerce include a website, email, intranet, extranet, LAN, and wireless area network. In this project, a real commercial dataset, namely the Brazilian e-commerce public dataset consisting of 100,000 orders made from 2016 to 2018 in Brazil, were involved. 4 visualization tasks will be carried out to answer the domain problems and interpret the findings from the dataset using Tableau. The first instance of electronic commerce over the internet occurred in 1994. Since then, internet usage has expanded beyond that of a networking medium, with many people using it as a marketing and transaction medium. E-commerce can now be built more simply than ever before since internet access is cheaper and many banks offer internet banking services that can help support the payment process in e-commerce. When product brand names and reputation are widely known among consumers, retailers seek to develop online storefront as an online retailing approach. In line with this, people are turning to the internet to purchase since it is more convenient than traditional shopping, which is often associated with anxiety, crowdedness, traffic jam, limited time, and parking space. Internet retailing is one of the world's fastest expanding industry, with substantial implications for traditional commerce. Hence, it is crucial to understand the important factors that affect consumers' purchasing decisions through e-commerce. The domain of this dataset that we'll be going to use in this project is e-commerce. To elaborate more on this, Ollie's is the largest department store in Brazilian marketplaces. Merchants will list their products and sell through the Ollie's e-commerce store. After a customer purchases the product from Ollie's, a seller gets notified to fulfill the order. Ollie's logistic partners then ship the product directly to the customers. Once the customer receives the product, feedbacks will be collected from customers by a satisfaction survey sent through email. Details of the datasets will be discussed in the next slide.
Hi, I'm Neil. I will explain the data extraction of this project. The data we use is an 8-table relational database that joined together with 52 attributes. There is 24 other attributes like geolocation, timestamp, price, etc. Another 28 attributes are categorical, such as ID, price category, and order status. We explore 4 different aspects on the Ollie's e-commerce platform. The first visualization task is to analyze the shipping delay and review score. This task aims to compare the feature about the delivery delay and review score of each seller. The first visualization task is to analyze the shipping delay and review score. We need to verify whether shipping delay will affect review score or not, so that the customer can consider trading with those sellers with low delay. The next task is to determine the payment value over time. This task aims to discover trend of payment value to track the profitability of this e-commerce platform. Through this visualization, additional components like outlier and more information about payment value like top payment type can be identified. Besides, it is important to explore on seller-customer network. The primary goal for this visualization is for users to enjoy on network topology, which attempt to answer questions like who is the customer of the most active seller. We also need to investigate relationship between the derived freight ratio and the distance of seller-customer. The last visualization task is about customer retention rate. By discovering the trend of customer retention, the e-commerce platform can be aware of the sustainable revenue brought by the repeated customer.
Now, I will summarize the visualization idioms we used for each task. For task 1, we are interested to know the distribution of shipping delay and review score across different locations, so we used geographical map to visualize it. In addition, we also used a heat map to summarize the rating score of each seller because heat map is good in showing overview of data. For task 2, we are interested in the total payment value over time, so we used line chart to visualize it because we can easily notice the increasing or decreasing trend from the line chart. Besides, we also interested in the top product category in terms of payment value, so we used bar chart to visualize it. Because we can easily understand which product contributed to the highest payment value through the length of the bar chart. We also used pie chart to visualize the most preferred payment type in terms of payment value. For task 3, we are not only interested in exploring the seller's customer's network topology, but also like to superimpose the network on the map. so that we could know how far each seller extends their networks to. For task 4, we are interested in the customer's retention rate over time. We used bar chart to visualize it because we can easily spot the trend. Furthermore, we're also interested to see the overview of customers' retention rate, so we used the heat map to visualize it.
Hi, Dr. Intan, I'm Lee. Let me present the related work of this project. According to Matus Jaslansky et al. In 2022, they have provided the visualization plot to show density distributions of payment value and transportation costs in groups of first and second purchase. One of the weaknesses of the idiom is that it is static representation and not interactive to the users. In addition, they have also conducted spatial analysis to explore geographical pattern of review score and payment value. We can notice that they encode the highest review score as dark orange, which may perceive wrongly as bad rating. One suggestion is to encode the highest review score as green color and the lowest to be encoded in red color. Besides, another paper by Eldick et al. Has analyzed the state count of HDI and review incidents across regions. There are two states that is different from other states, which are North and Northeast. The explanation is that the mode of case count is categorized for the low-medium HDI only appeared in North and Northeast, and as well that the proportion of giving review is lesser in low-medium HDI category compared to the rest of the regions. After that, let me begin with the visualization analysis of shipping delay and review score. I would like to show you a demo of the idiom. A new attribute of delay is derived and each seller location is encoded in geographical map and the average rating is encoded in color. Besides, we have used a heat map to visualize the clustering pattern. Then we integrate the idioms in multiple views that we can use a filter panel to control the average shipping delay of sellers. Back to here, buyers are less likely to shop in e-commerce again if purchases are not delivered on time. Hence, it is important to know which sellers have always with high delivery delay. Therefore, we need to derive a new attribute of delay where the formula is shown in the slide. The geographical mapping telling us that the sellers that has average delay more than 1 day are clustered on the coast of Southeast region. Besides, we have also used heat map to visualize the clustering relationship. We can identify clearly that the proportion of bad rating that the sellers always delay has a higher proportion. And then we have integrated idioms in the dashboard. We can know that there are 16 sellers that always delay are clustered on the coast of Southeast region. To summarize for task 1, we have used multiple views by encoding the table in geographical map and heat map. The tasks are to explore geographical pattern and look out for details. The strength is that it allows dynamic filtering and the weakness is the delay attribute is limited to a time format of days.
From the perspective of e-commerce platform, it is important to understand the behavior of payment value. A dashboard consists of 6 worksheets will be used showing the daily overview of payment value and total payment value for each hour, days of the week, month, product category, and payment type. Except for the payment type, the deeper the color, red, indicates a larger order item count, or the lighter the color, yellow, indicates a lower order item count. Besides that, we can interact with this dashboard. For example, we can see that there is an outlier on November 24, 2017, which is also the Black Friday. So when we select this day here, we can see how the order category, payment type, and order by hour change for that day. We can also select a specific category. Or selecting both the category and the date, and other worksheets will be filtered accordingly. We can notice the payment value behavior pattern from this overview. On Mondays, people spend the most, while on Saturdays, people spend the least. The average active time on the e-commerce platform is from 10 AM to 10 PM. The month with the lowest payment value is September. The top 3 item categories with the highest payment value are health and beauty, watches and gift, and bed, bath, and table. The majority of the transactions are paid with a credit card. We can also observe that the color of bed, bath, table is darker, which means more items from this category are sold, but the item price for the watches gift category is higher. This is the summary of the payment value dashboard.
Next, I will explain on the seller customer network. First, let us get familiar on the visualization by having a demo. The domain problem is to find customer distribution of the top sellers. One simple use case is to let users to simply select on the seller ID that they are interested on. This visualization shows the network information, especially the relationship on geolocation spatial. The user can intuitively perceive the location of seller and their customers. Besides, by applying the filter on the right panel, it is possible to reduce the number of seller network. For example, if I set the minimum number of order items to 1,500, the order can reduce to only 3 sellers. Moreover, we apply a sample widget on the seller ID so that the user can know the distribution of payment value based on each seller. For instance, a larger bar here implies that the seller has a larger payment value. One of the highlights is that the user can obtain accurate information on the pop-up when hovering on the network, such as the seller ID, freight ratio, order item, and the payment value. From the result, the seller with highest gross merchandise value earns nearly 250,000 Brazilian real, while the most active seller sold 1.8 thousand items across these 3 years. Both of the sellers stay in Sao Paulo state, but their customers are distributed evenly across the whole Brazil. Besides, we also noticed that the freight ratio is lower when the seller-customer distance is shorter. Hence, customer can try to engage a closer seller to minimize the shipping cost. In summary, we use seller-customer network to derive spatial and network from the table dataset. We encode the network graph with the amount of line and the channel of position on the map. We can select any seller to change the view of network from one seller to another. We also apply filter to reduce the seller on the map. The main purpose of this visualization is to enjoy network topology. One advantage of this chart is it shows the network relationship on the geospatial map. However, we need to preprocess the data to make the chart, and it becomes hard to differentiate when not applying any filter.
For task 4, we want to determine the customer retention rate. If there is high customer retention rate, we can know all this e-commerce is providing a very good service. Whereas, if the retention rate is low, we can know something is wrong with their services. I will first demo the visualization idioms that we created for this task. You can also access to it via this link. First, we use two heat maps to visualize the overview of retention rates. First one shows the number of customers retained. The second one shows the retention rates. Arrow marks are used where the data are separated and aligned into the matrix indexed by month, rank, and month of cohort. The data in first and second heat maps are colored by subscribers and fraction retained, respectively, where darker green indicating more subscribers or higher retention rate. Two heat maps are partitioned side by side in the dashboard, and link highlighting is set to coordinate these two idioms, meaning that if we click on any information in first heat map, the same info in second heat map will be highlighted too. The data are annotated to give clearer picture of retention rate since the color of row retention rate is difficult to differentiate. Then, bar chart is used to present the distribution of customers retained over months. Line marks are used where the length of the bar representing the number of subscribers. Based on the heat maps, we can see that the highest retention rate is just 1%, which is very low, meaning that something is wrong with their services. All these e-commerce stores should focus more on improving their user satisfaction to retain all customers to maximize their profit. We also noticed that the retention rate in September 2017 is slightly better than others because it has 1% retention rate in 2 consecutive months, which probably tells us that the marketing event in September 2017 is more successful than others. We also can notice that the number of customers retained decreases over time from the heat maps. But from bar chart, the decreasing trend is more obvious. This is the summary of heat maps, and this is the summary of bar chart. As a conclusion, we have successfully created idioms for each task. We identify 16 problematic sellers which always delay their delivery to the customers, especially in Southeast region. Besides, we also explore the spending trend and top product category in all this e-commerce. In addition, we also explore the seller's customer network. Lastly, we discovered that all this e-commerce has a very low customer retention rate. Throughout the project, we experienced the benefits of using visual analytics. For example, by using GeoMap, we could easily discover the review score distribution across different regions. Visual analytic approach also enables us to make sense of the network data. Besides, by interacting with the dashboard, we can discover even more powerful insights such as the top product in specific time. This is very convenient and powerful. That's all from us. Thank you.